In all of the dividing radicals problems that we've done so far, the denominator has always just worked out nicely and had a nice square root. That won't always happen, and when you get a denominator that doesn't simplify nicely, then what you have to do is something called rationalizing the square root. Basically, this is just multiplying by 1, some fancy kind of 1, so that things simplify the way that you want. So for example here, 2 over the square root of 5. 5 does not have a nice square root, and I can't simplify that. So what I'm going to do is I'm going to multiply by some fancy version of 1. When I multiply by 1, I'm not changing the value of anything. Any number times 1 is itself. But I can write 1 in more than one way. I could write 1 as 2 over 2 or 4 over 4. In this case, I'm going to pick whatever this denominator is, and I'm going to multiply by root 5 over root 5. Root 5 over root 5 is really just 1, but I'm going to be multiplying 2 over root 5 times root 5 over root 5. Then you'll need to remember your rules from elementary school when you multiplied fractions, how you multiply the numerators to get the new numerator, and then you multiply the denominators to get the new denominator. Now, 2 times root 5 is just 2 root 5, and then in the denominator, root 5 times root 5 is root 5 squared, and don't forget that when you take the square root and then you square something, they're inverses, so they're going to be undoing each other. So the square root of 5 quantity squared is just 5, and we end up with 2 root 5 over 5. Now you would check to make sure that 2 over 5 doesn't reduce. In this case it doesn't, so this is our final answer, 2 root 5 over 5. Alright, let's try 2 more of these. First we'll look at the square root of 16 over the square root of 12. Now I noticed that 16 over 12 does reduce, and sometimes it's easier to work with smaller numbers, and using our quotient property from the last video, I know that this is the same thing as the square root of 16 twelfths, and 16 twelfths is 4/3, and then I can use the quotient property again and change that to the square root of 4 over the square root of 3 and get 2 over root 3. Now it's not simplified yet because I'm not allowed to have a radical in the denominator, and there's no way right now for me to simplify this root 3, so that's when I rationalize. I'm going to multiply by a fancy version of 1. In this case my denominator was root 3, so my fancy 1 is root 3 over root 3. And 2 times root 3 is 2 root 3. And the square root of 3 times the square root of 3 is the square root of 3 squared. And when you square a square root, those are inverses. So that's just a 3. And 2 over 3 doesn't reduce anymore. So this is my final answer, 2 root 3 over 3. Next I'll do the same thing with the square root of 6 over square root of 20. Now I'm going to show a little less work on this one than I did the last one. You notice that I could have just skipped some of these steps, and I could have taken 16 over 12 and reduced it to 4 over 3 without really putting it back into the fraction and then splitting it up again. Technically that's the work that I'm doing, but sometimes we like to skip a few steps so that we don't have as much writing to do. So rather than putting the 6 over 20 together into one fraction and then splitting it up again, I'm going to skip showing that part, but the square root of 6 over the square root of 20 reduces to the square root of 3 over the square root of 10. Square root of 10 does not have a way to reduce nicely, so I'm going to multiply by a fancy version of 1. Remember, it's whatever your denominator is. So we're multiplying by root 10 over root 10. Use our product property of radicals from the first part of this lesson. Root 3 times root 10 is root 30. And I'm also going to save some work here. Root 10 times root 10 is root 10 squared, and a root and a radical cancel out. They're inverses, so I would just get 10. Now, one last thing that I would want to do is I would want to make sure that the square root of 30 does not simplify any further. So I would do like a quick factor tree, maybe in my head, maybe off to the side, just to make sure that I can't simplify the square root of 30 any further. So 30 is 2 times 15, and 15 is 3 times 5, and no, there's no groups of 2, so square root of 30 over 10 is as far as I can go in simplifying this one.